Intro music. So let's talk about a specific week, September 11th to 18th, 2025.
Right.
Because something really shifted in AI funding then. It wasn't just about bits and bytes anymore. It got physical.
Yeah, exactly. That was the week we saw that huge headline, Figure AI, the robotics company. They pulled in a Series C round of over $1 billion.
$1 billion for a humanoid robot. I mean, that's such a clear signal, isn't it?
It really is.
It says the next big step for AI, it isn't just about, like, thinking faster inside a computer. It's about doing things, actually interacting with the real world.
Mm-hmm. Welcome to the deep dive. We've basically spent time digging through, 20 major funding announcements just from that one week.
Yeah, quite a stack.
And we're trying to see, where's the smart money actually going? What are the real trends here for you?
So our plan for this deep dive, we've grouped these huge investments into three main buckets, three themes that seem to define what's coming next. First, we're looking at AI literally taking physical shape. Robotics, advanced manufacturing.
Right, the moving into the physical.
Yeah.
Then second, we got to look at the infrastructure needed for all this. We're talking specialized chips, security layers, the stuff that makes it all run.
Exactly. And third, how AI is starting to automate really specialized high-stakes work. Think science, complex coding.
Got it. So let's start with that billion-dollar bet, the physical world stuff.
Yeah, let's dive in. The biggest signal has to be that capital flowing into AI that can, actually touch and manipulate things. Figure AI's deal on September 16th was, well, it was the headline.
It really was. And they're building general-purpose humanoid robots. So basically, robots shaped like us. 2 arms, 2 legs, a torso.
The idea being the sort of ultimate general-purpose machine.
All right.
Something that can work alongside us.
Yeah, and critically, operate in our world. Use the tools we use, navigate spaces designed for humans. That's the key.
Which, directly hits things like labor shortages, automating jobs that are maybe dangerous or just hard to fill. Logistics comes to mind immediately.
For sure. But, okay, let's think about that $1 billion. That's a massive amount for a robot that's, let's be honest, still mostly in development, right?
Yeah.
What are the risks investors are taking on there besides just the tech not working out?
That's a good point. I think maybe the biggest hurdle isn't always the tech itself. It's regulation. It's public acceptance. This kind of money, it's not just funding lab work.
Right.
It's pushing to scale up manufacturing, deploy with partners. Like now, it feels like investors are betting the regulatory side will sort itself out quickly, or maybe they intend to push it.
Okay, that makes sense. It's a bet on deployment happening soon, not just maybe someday. And it connects to other things happening that week, right? It's not just the robot.
Exactly. We also saw Divergent Technologies raise $290 million. They're building something called DAPS, the Digital Adaptive Production System. This is like manufacturing 2.0.
Yeah, DAPS, it mixes AI design, 3D printing, and then robotic assembly. It's a completely different way of thinking about production lines, moving away from those rigid old-school factories.
Totally. Instead of a factory built for just one specific part, DAPS is modular. It's defined by software. That means you can make complex things, maybe aerospace parts, custom car components, way faster and cheaper.
Oh, okay. Just imagine scaling that DAPS tech.
Yeah.
You could rapidly spin up production for, custom parts for almost anything. Cars, planes, spacecraft. That software-defined flexibility is that speed.
It really is. And then there's PassiveLogic. They pulled in $74 million in the same space. They call what they do generative autonomy.
Generative autonomy.
Their system stands a whole building, like a commercial office building, creates this super detailed digital twin, and then the AI generates the entire control system for it, HVAC, lighting, everything. It just designs and optimizes it automatically, replacing a ton of manual engineering work.
So it's complex physical system controlled, but done by software based on a scan.
Yeah.
It's pretty advanced.
So back to Figure AI for a second. If that $1 billion means investors expect mass production and deployment soon, what does that signal about their confidence in these other pieces like DPS and PassiveLogic, the things needed to support those robots?
It tells me they think the support infrastructure problem is basically solved or solvable very quickly. They believe we can make the custom parts the robots need and manage the complex environments they'll work in.
Okay, so that covers the what's AI getting physical. But that kind of ambition, it needs some serious power behind it, right?
Right.
Which brings us to the infrastructure investments.
Exactly.
Yeah.
Theme number 2.
Yeah.
The infrastructure. Speed, security, making sure AI can be everywhere. And the big name here was Groq, G-R-O-Q. They raised a huge $750 million, right, Groq. They build specialized chips for AI inference. They call them LPUs, language processing units. Maybe just quickly clarify inference for everyone.
Sure.
Inference is basically just the AI using its training, taking its learned model and applying it to give you an answer or perform an action in real time. LPUs are specifically designed to run those big language models very, very fast. Less lag.
So they're tackling the latency problem, the spinning wheel of death when you're waiting for the AI.
Pretty much, yeah.
Because slow AI is just a bad experience, especially if you're trying to use it for real work. Groq's tech aims for that smooth, real-time interaction you need for widespread adoption.
It makes you wonder, though, if Groq really nails this instant response time for powerful AI, what does that do to the established players like the big GPU makers? Does the whole competition shift from training speed to, like, user experience speed?
I think it suggests exactly that. The market seems to be saying, okay, the models are smart enough for now, let's make them fast and cheap enough to actually use everywhere. The bottleneck has definitely moved.
Yeah, that tracks. And we also saw money going into the plumbing, the system infrastructure. Upscale AI raised $100 million. They're building an open standard AI networking platform.
Open standard being key there. It stops companies getting locked into one vendor. It's like creating a common language, so AI systems running in the cloud or on a company's own servers or even on tiny devices out in the field can all talk to each other easily.
Interoperability. Super important for big companies.
And if you're connecting all these systems, you absolutely need security. We saw two big plays there. Area raised $100 million for general enterprise AI security, kind of the essential tools for managing access, checking for threats across lots of different AI models.
The basic blocking and tackling. And then Irregular raised $80 million, and they focus specifically on securing the frontier AI models.
Right, the really big cutting-edge ones from places like OpenAI or Google.
Exactly. And they're worried about new kinds of attacks, things like data poisoning, where someone messes up the training data.
Right.
Or prompt injection, which is basically tricking the AI into ignoring its safety rules and doing something it shouldn't.
Yeah, I still wrestle with understanding prompt injection vulnerabilities myself sometimes. It's genuinely hard to make these flexible models consistently stable and safe. So yeah, I appreciate companies focusing just on that defense layer. It feels really necessary.
So when you add it up, Groq's speed focus plus the security funding from Area and Irregular, that's over $1 billion just on inference and safety in 1 week.
Yeah.
Does that suggest that the main thing holding back wider AI adoption isn't that the models aren't smart enough, but that they're perceived as too risky or too slow?
I think yes. It feels like the intelligence is largely there, at least for many tasks. The money is now flooding in to make that intelligence fast, reliable, and secure enough for businesses and people to actually trust it everywhere. That's the foundation for the physical stuff we talked about first.
Okay, which leads us nicely into the third major trend, automating the experts.
Right. Using AI not just for general tasks, but to speed up discovery and efficiency in really complex, specialized fields.
And the standout here, maybe the biggest surprise for some, was Lila Sciences. They raised a huge $235 million in a Series A. That's massive for an A round.
It really is. And what they're building is, well, they call them self-driving labs, AI-powered autonomous research labs.
Self-driving labs. Okay, break that down.
It's like a closed loop. The AI designs an experiment. Robots physically carry it out. Then the AI analyzes the results and uses that to design the next experiment. It just runs continuously, 247.
Wow. So it takes the human scientist out of the loop for the day-to-day bench work.
Essentially, yeah. It lets discovery happen at machine speed. You can see the potential impact on things like discovering new drugs or materials. It's potentially profound.
But building a fully automated lab sounds incredibly expensive and complicated. What's the immediate hurdle they have to jump over to make that huge Series A make sense?
Beyond just the pure engineering challenge, I think it's standardization. Real-world labs are often messy, full of custom equipment. To make a self-driving lab work at scale, you need to standardize everything, the hardware, the processes. That's a massive task.
But the payoff, if they can do it, removing that human bottleneck from discovery. Yeah, I can see why investors are interested.
And sticking with health, we saw Conceivable Life Sciences get $50 million. They're automating the IVF lab using AI and robotics.
Okay, so taking those complex manual steps and fertility treatments and automating them.
Right. The aim is better consistency, maybe higher success rates, and making these treatments more accessible because automation could lower costs.
Makes sense. And then in a totally different vertical, software development, which AI has been targeting for a while, CodeRabbit raised $60 million.
Yeah, an AI code review platform.
So the AI reads new code developers write, finds errors, suggests fixes, even summarizes what changed.
Exactly. It speeds up the whole development process, improves the quality of the code, and hopefully frees up senior engineers to think about bigger picture problems instead of just line-by-line reviews.
And there were others too, right? Like Apex raising $200 million for satellite platforms, Greenlight getting almost $50 million for construction permits.
Yeah, lots of vertical-specific plays getting serious backing.
So looking at this whole category, automating science labs, IVF procedures, code reviews, these are things we used to think needed deep human expertise and judgment for every step.
Hmm.
Is this story here just replacing those experts? Or is it changing what the expert does?
I think it's fundamentally changing the role. It's freeing up the experts, the scientists, the doctors, the top developers, letting them focus on strategy, on the really hard problems, on creativity, while the AI handles the more routine execution parts. It lets the humans move up the value chain. Mid-roll sponsor read.
All right, so let's try and pull this all together. Looking back at that week in September 2025, what did these big funding rounds really tell us?
I think the biggest message is that AI is moving out of the purely digital realm. It's stepping into the physical world in a serious way.
Yeah, first you saw that huge push towards commercializing physical AI, that billion for figures robots, plus the money for advanced manufacturing like DPS. It signals readiness for actual deployment.
Second, you can't have physical AI without the right engine. So a massive commitment to the infrastructure, the need for speed, like Groq's chips, and the absolute necessity of security and stability from companies like Irregular and Area, making AI trustworthy at scale.
And third, the money flowing into what you call closed-loop automation, systems that can run entire complex workflows themselves, whether it's discovering drugs or reviewing code, supercharging specialized fields.
Yeah, the big picture takeaway feels like a clear pivot. We're moving from AI that just thinks or predicts to AI systems that operate, that build, that manage things in the tangible physical world.
So that phrase from the source material about the figure AI robot, calling it the ultimate general purpose machine, if they actually achieve that, if it gets real dexterity, real autonomy, what's the final implication?
Well, think about it. If that machine can truly operate anywhere a human can, what space that we've designed, a factory floor, a building site, even just a regular kitchen, won't eventually be designed with autonomous machines in mind or be occupied by them?
That's a pretty profound thought.
That feels like the core message behind that billion-dollar signal. That's the future. These massive investments are betting on a deeply physical, increasingly automated world. Thanks for joining us for this deep dive.
Yeah, I hope this gives you a clearer picture of where things are heading in this incredibly fast-moving space. Outro music.